the reason for minimizing void is make sure the thermal performance is good and it package doesn't heat up. So if it doesn't heat up, then you're going to have much better performance. I just will touch on quick 3 methods as to how we can minimize voids. One is what we call solid solder deposition, and the second method that's becoming somewhat popular is using a preform, which is, just think of it as a sheet metal made of solder that's being used. I'll talk about how that's done, and the most common, of course, that where you don't have to do something extra is controlling the process. Now, this SSD, the solid deposition, has been around for a while. I'll describe that in a second, what that is. What the solid solder deposition is nothing more than applying the solder paste when the PCB is made. That's what you're doing. So what they will do is when they make the PCB, the printed circuit board, they will coat that and then basically deposit using a stencil, deposit a pretty thick solder on that stencil, all right, on that board, and then reflow it. And after that, they will, while what's being reflowed, they will have some other screen on top of it to push it down so that the pads become flat. Now you are adding another process step. So especially the reason this thing was done in early days, and it has been around since mid-80s. So it was done for very fine pitch packages when the pitch is 20 mils or less, like 0.4 millimeter and so on. It becomes very hard to print in a normal production environment. So the PCB people, the board fabricators came up with the idea that let's provide printed solder paste. So the user, all they have to do is apply flux and they can solder these other components. So that's a new application, but when it was invented, if you will, in mid-80s, it was for fine pitch to prevent bridging. And it's not that common process today because you have to pay, your cost for the PCB obviously will go up if you use this process. So not that much use, but that's an option. The second one here on slide 59 is basically there is a lot of people have done some work here, and I have given that reference, but you do the printing of the paste like you normally do, if you will, that's on that board, and on the center of the BTC thermal pad you place a preform, which is nothing more than a sheet of this solder, which will be like, let's say, any surface mount component, and it will come on a tape and reel, and you buy them on a tape and reel, like 5,000 of them on one tape and reel. And after you have placed that preform, now you're going to place the BTC on top of that preform. So when now you're going to go reflow, what people have discovered is you can almost reduce in half, at least some people have claimed, and they have found in their results that the void goes reduced in half. But not necessarily everybody has bought into this, and I think essentially it has to do with the cost. But anyway, this is an option. All right, so that's your second option. Third option, obviously, so I think in this slide 660, I just described the process already as to how this is applied. So you're printing the paste, taking the pick and place machine, dipping it in the flux, and then pushing it on that paste, and then reflow it. So that's the process. The slide 61, this is the most common, and this is what you have a lot of control on. And when it comes to void, it's very complicated things. It's not just, there are a lot of causes. So I have put this in a various types of bucket, if you will. Paste can cause the void. Reflow profile can cause the voids. PCB and components can cause voids. And in general, there are other stuff. So let's take each one of them.